So here's a velocity graph, and this is the type of quizzes we have dealing with this particular velocity graph, or these particular sets of questions. And again, remember the acceleration is the derivative of the velocity, so the derivative does not exist when there's a corner, so our acceleration does not exist at t equals 1, 2, 4, 6, 7, 8, and 10. This is all with respect to t. So the first question is, when does a particle move forward? Well, it moves forward when the velocity is positive. Here the velocity is 0, and it's 0, so it moves forward when it's greater than 0. That's greater than 0 between 2 and 8, so that's when time is between 2 and 8. So that'd be the open interval 2 to 8. Okay, when does a particle move backwards? Well, it moves backwards when the velocity is negative. Well, the velocity is negative here at t equals 0. And it's negative all the way up until we get to 2, where it's 0. So it's to 2, and that's open. And then we have to go over here until we get to 8, and it's negative after 8. So we put a union here. And then we could say from 8 until 11. Oops, sorry here. Excuse me, that should be 8 to 11. And then 11 is closed, so there we go. So from 8 to 11. After 8, it's 0 at 8, so the velocity is 0 at 8, and then after 8, the velocity is negative all the way over here, and it's even negative at 11 because it's way below the 0 there. All right? Okay, so I hope you understand the first two questions about velocity, positive or negative. Okay, when does a particle speed up? Now remember, it speeds up when the velocity and the acceleration have the same sign. Now the velocity is the derivative or the slope of the, acceleration is the derivative or the slope of the velocity graph. And when we have an endpoint, we just look at the right-hand derivative. So here it's negative. So it's negative right at 0, and then all these other points here. The slope is negative, or the derivative is negative, and the right-hand derivative is negative, so that's what we use for the 0 point. So it's negative from 0 all the way till we get to 1, the derivative or the slope of the velocity function. That means the acceleration is negative, and the velocity definitely is negative, so we're speeding up from including 0 to 1. All right? But at 1 we don't have a velocity, so we don't have anything, so we have to keep it open at 1. We don't know what's happening at 1. Okay? That's when it's moving, whenever, and another way of thinking about that is whenever the graph is moving away from the 0. It's also moving away from the 0 after 2. Remember, it's not defined at 2, so the acceleration is not defined at 2, so we can't really talk about the speed. But after 2, it's moving away from 2 to 4. And from 2 to 4, the acceleration is positive, the slope is positive, and the speed is also, or the velocity is also positive. So since the velocity is positive, that means it's above the graph. It's above the graph, so the velocity is positive, and the slope of the velocity, which is the acceleration, is also positive. Remember here it doesn't exist, so we don't worry about these corners. So keep that open. Okay, then it's also moving away from the 0, or the slope is positive and the velocity is positive between 6 and 7. And it's also moving away from the 0, or the slope is negative and the velocity is negative between 8 and 10. Okay. So all that's where the particle speeds up. Okay. 0 to 1, 2 to 4, 6 to 7, and 8 to 10. Okay, when does it slow down? Well, it slows down when it's moving towards the 0, or whenever the velocity and the acceleration have opposite signs. Here the acceleration of the slope is positive, but the velocity is, since it's below the graph, is negative. So it's slowing down from 1. Now we don't have anything in 1 because it's a corner, so we'll open at 1. I'm sorry. From 1 to 2. Okay. And then what else do we have? When else is it moving towards a 0? So it's from 1 to 2. Nope, 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 nope. And then from 7 to 8. And again, you can see that the velocity is positive. It's above the graph, but the acceleration, which is the slope of the velocity, is negative. But we have a corner here, so we can't say anything what's happening at 8 because the acceleration isn't defined. But after 8, it's moving away, so it's like speeding up. And then over here from 10 until 11, we are again slowing down because the acceleration here is negative below the graph, but the velocity is negative because it's below the graph, but the acceleration is positive because the slope is positive. So opposite signs, it means it's slowing down, or you can think of it the fact that it's just moving towards the 0. So that's going to be union 10 to 11. Now at 11 seconds, you can see that, again, the slope here is going to be positive and the acceleration, the slope is positive, that means the acceleration is positive. And the derivative would use a left-hand derivative, so that's going to tell us it's also the left-hand derivative is positive. So the acceleration right here does exist. So the acceleration is positive and the velocity is negative, so the particle is still slowing down at 11, so we'd have it closed. Bracket there. Okay. All right. When is the particle's acceleration positive? Okay. So when the acceleration positive, so this would be letter C, A, B, C, D, E, excuse me, E. So it is positive from 1 until 2. And then from 2, remember, it doesn't exist, so we don't say whether it's positive or negative at this corner because the acceleration is the derivative of the velocity. But it's positive from 2 to 4 also. Whenever we're talking about acceleration, think of it as the derivative of the velocity. And it's also positive from 6 to 7. And finally, from 10 to 11. And there should be a bracket because it does exist at 11 because we use it's the end of the interval, so we do use the left-hand derivative. See, this is our domain from 0 to 11, so that's what we're talking about. Okay? Letter F. So that's pretty much when we're going uphill. Uphill here, uphill here, uphill there, and uphill there. That's when the acceleration is positive, when that's the slope of the velocity. We just have to be careful on the endpoints, okay? Or on the endpoints of these intervals. All right, letter F. When is the acceleration negative? So whenever we're going downhill. And again, we can include 0 here because we do have a slope here at 0, so that's going to be closed at 0 to 1. It's going downhill. Union. And then 7 to 8, it's going downhill. And then union 8 to 10. Okay. Alrighty. And then G, when is the acceleration 0? Well, that's whenever the slope of the velocity is 0, and that's just going to be right here from 4 to 6. And again, no endpoints because we've got corners there. Okay, and finally, When does the particle move at its greatest speed? Well, this is, I'm going -2, here I'm going +3, and here I'm going -2, so the biggest number, I just think that the absolute value of the biggest, the absolute value of this is 2, the absolute value of this is 2, the absolute value of this is 3, so that's the biggest speed, or the greatest speed. So that's going to happen at t equals 7. Okay. So there you go. So I hope that makes sense.